G'day team, welcome back. So we're going to be moving swiftly on from the quadratic formula and looking at the discriminant of a quadratic. So the discriminant is actually involved with the quadratic formula, so it's a good follow on from the quadratic formula. So we actually denote the discriminant with the symbol delta. So delta looks like this triangle with one bold side, so it's a Greek letter, okay? So to the discriminant, so delta, the discriminant is equal to b squared take 4ac. So hopefully that's ringing a bit of a bell from the quadratic formula, and it's actually what is under our square root in the quadratic formula, as you can see here. So the quadratic formula is x equals negative b plus or minus the square root of b squared take 4ac all over 2a. And as you can see, we've replaced b squared take 4ac with our delta for the discriminant. So, a few things. If the discriminant is greater than 0, then the square root of the discriminant is a positive real number. So that means we're going to get two distinct real roots. So at the moment, we're diving into classifying roots of quadratics. So if the discriminant is positive, you're going to get two distinct real roots, okay? And they look like this. So negative b plus the square root of the discriminant over 2a, and x equals negative b take away the square root of the discriminant over 2a, all right? If the discriminant is equal to 0, then x equals negative b on 2a, all right? And that is the only solution. And we call this a repeated or a double root, okay? So in this case, the quadratic will touch the x-axis at this x-coordinate here. And then last but not least, if the discriminant is less than 0, that means the square root of that discriminant is not a real number. So we say there are no real roots, okay? So that means it will not touch the x-axis at all, all right? So when you're asked to classify the roots of a quadratic, you check by calculating the discriminant. You'll either have two distinct real roots, a repeated or a double root. You can use those interchangeably, or you'll have no real roots, okay? Just one last little thing. If a, b, and c, so the coefficient for the x squared term, the coefficient for the x term, and the constant coefficient, if they're all rational and the discriminant is a square, so either 4, 9, 16, 36, 25, all those square numbers, then the equation has two rational roots which can be found by factorization. So using your null factor law, using sums and products, using completing the square, okay? You can find them if a, b, and c are rational and the discriminant is a square number. All right. So a question with that looks like this. So we'll do an example together. So if I have a quadratic 2x squared plus 6x take away 3 equals 0, I want, if I say using the discriminant classify the roots. Okay, so you often see questions that look like this. So if it says using the discriminant, we know straight away we're going to be using our discriminant, which is our b squared take 4ac, right? And remember, I like to label my coefficients in my quadratic, so it's super easy to see which value goes where. So substituting in b squared, so that's 6 squared, take away 4 times by a, which is 2, times by c, which is negative 3. All right, so 6 squared is 36. 4 times 2 is 8. 8 times negative 3 is negative 24. And we've got that negative sign there, so we're going to add 24. 36 plus 24 is 60. All right, so because delta is greater than 0, we have two distinct real roots. All right, so remember, if the discriminant is greater than 0, we have two distinct real roots. All right, so that's how we would classify the roots of a quadratic using just the discriminant. All right, we'll see you guys next time.